Okay, so this video will cover Chapter 4 of Geometry and specifically Section 4.1 to 4.2. So by the end of this video, you will know a lot of new vocab and rules that have to do with angles. So first, let's go over some vocab. So complementary angles are angles whose measures add up to 90 degrees. So two angles whose measures add up to 90 degrees. So that'll look something like this, where we have the two angles that it might be 50 degrees and 40 degrees, who add up to 90 degrees. They don't have to be sharing a side. They could be like this, where this is 60 and this is 30, or something of that sort. Supplementary angles are very similar. They're two angles whose measures add up to 180 degrees. So they look something like this, where you could have, say this is 50 again, then this would be 130 degrees. And again, they don't have to share a side. They could be like that. Vertical angles are interesting because, so say you have two lines that intersect like this, and then you can number these angles. Then we can say that angle 1 and angle 3 are vertical angles, and angle 2 and angle 4 are vertical angles. So they're the pairs of angles across from each other in intersecting lines. Okay, so then moving on, a linear pair of angles is a little more complicated. They have to be on the same line, and they have to share a side, like this. And so they look like supplementary angles, and they are. They always turn out to be supplementary angles because they lie on the same line and share a side. So now we're going to move on to some conjectures about these angles. So when you have two vertical angles, we can actually make a conjecture about them, which says if two angles are vertical angles, then they're equal in measure, which we can actually observe here. So look at these sets of vertical angles, and look how they are actually equal in measure. And then I touched on this earlier, but if a pair of angles is linear, then they're also going to be supplementary because their measures are going to add up to 180 degrees. Okay, so now in 4.2 we have some more vocab. So parallel lines are lines in the same plane that never intersect. So same plane, never intersect. And there are a lot of really cool properties about parallel lines. So a transversal is if you have two lines, any two lines, then the transversal is going to be the line that intersects these two coplanar lines. And this actually creates some angle pairs that we're now going to talk about. And a useful thing to know also about parallel lines is this symbol right here signifies that two lines are parallel. Okay, so for these next few terms, we need two lines and a transversal. And then we're going to number them to make it easier. So corresponding angles are pairs of angles in a situation like this that are in the same spot but on different lines. So an example of this is 2 and 6 or 4 and 8. Alternate interior angles are angles such as 3 and 5 that are on opposite sides, so they're alternate, but they're on the interior. So this is going to be the interior, this and this is the exterior. So example 3 and 5 or 4 and 6. Alternate exterior angles, you might be able to guess, are angles such as 1 and 7 that are alternate, they're on different sides, and they're on the outside, the exterior. So 1 and 7 or 2 and 8. So let's say that these two lines are parallel. Then we can make some really interesting conjectures about these sets of angles. So the parallel lines conjecture says that if two parallel lines are cut by a transversal, just like we looked at just before, then corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. So all the pairs of angles we just looked at are going to be congruent. And we can actually split this into 3 different parts. The corresponding angle conjecture says that if two parallel lines are cut by a transversal, then corresponding angles are congruent. And then the alternate interior angle conjecture says that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. The next one, alternate exterior angles. If two parallel lines are cut by a transversal, then alternate exterior angles are congruent. And then we have the converse, which says that if two lines are cut by a transversal to form pairs of congruent corresponding angles, congruent alternate interior angles, and congruent alternate exterior angles, then we can conclude that the lines are parallel. So now we're going to move on and see this in an example diagram. So here we can look at this and we can see that the corresponding angles, such as 2 and 6, they look congruent because they are. These two lines are parallel, K and J. And the alternate interior angles, 3 and 5, they look congruent. The alternate exterior angles, 1 and 7, also look congruent because they are. So now we're going to go over one last term before we use all the information you've learned in a practice problem. So consecutive interior angles are another pair of angles in the same situation that we just had. They're going to be these angles right here. So this one and this one, where they're on the same side of the transversal and they're on the interior. So say we call this one 1 and this one 2. 1 and 2 are going to be consecutive interior angles, and so are 3 and 4 over here. And a really cool thing about consecutive interior angles is that they're actually going to be supplementary. So the measure of angle 1 plus the measure of angle 2 is going to equal 180 degrees. Okay, so you could be given a practice problem just like this, where you get two parallel lines and then a transversal, and then you're given one angle measure and asked to fill the rest in. And it's actually quite possible from all that we've learned. So we can start by filling in some vertical angles that we know are going to be the same. And then we can do alternate interior angles here and here are going to be equal by the alternate interior angles conjecture. And then we can do another vertical angle here. And then we just learned about consecutive interior angles. That's this and this, and we know that they're going to be supplementary. So if they're going to add up to 180, and this is 60, then this has to be 120. And now we can do another alternate interior angles. So this is also going to be 120. And then we can see that these two angles are going to be collinear. They're going to be a linear pair of angles. And we know that they're also going to be supplementary. So now we know that the supplementary angle to 60 is 120, so we can fill in the last two. And that's how, from just one angle measure, we can figure out every angle in a situation like this.